Hello, good afternoon. I'm Niranjan Domse. I work with New Research. I'm principal architect there. And last few years, I've been helping some of our clients build microservices. And that's what we're going to talk about today. So I'm going to talk about what microservices are, what benefits they bring, what kind of challenges we face when moving towards microservices. What we did to overcome those challenges, what tools we're using, and maybe walk through a quick walkthrough of how we build a microservice. And hopefully, if time permits, cover a couple of use cases that we have seen during our time with the customers. Okay. So the essence of microservices, in my opinion, is best embodied by the Unix philosophy. The core principle behind the way the Unix operating system has been built. So what the principle states basically is to take a complex problem and break it down into some smaller manageable pieces or units. And each of these components, therefore, does one small thing only and does it really, really well, has a clearly defined input-output, and we can use that to hook together multiple of these components to provide an overall functionality. So the success of Unix over all these years, it kind of is a great testament to this concept. And what microservices architecture does is takes this concept and extends it to the enterprise. So what does the microservices architecture say? Basically, it dictates that one service should focus on one business function only and should be a single deployment unit. The idea here is each service should be made as small as possible, kept as small as possible, handling a single specific business function. But the idea is, since it's small and focused on a business function, it should be able to do it very efficiently and very well. It also needs to be an independent deployment unit, which enables us to work with it independently, deploy it independently without much disruption when we are taking it to production and so on. Now, in an enterprise, business function is typically stateful. So what we need to do is give each microservice its own state, its own private state. Now, private state is really a key, fundamental tenet that makes the microservice truly, truly autonomous. Okay, so we have these smaller services. These are then hooked together by something like some standard messaging. They communicate with each other using messaging. Now, it's important to keep this messaging vendor agnostic messaging so that we are not tied to one particular technology. It keeps our options open, basically. Then the question of testing. We want each of the services to be testable as soon as possible and continuously. So you want it hooked up to a CI environment. Having an automated CI/CD framework is really important to be able to take a service from development to production quickly. Okay. So let's look at what the challenges we would face, or what we have faced, and what are seen in the industry. I'm sorry, I'm looking at the wrong slide. Beg your pardon. Okay, let's look at why microservices first. So since each service is doing one business function, and it's also an independent deployable unit. What that does is it lets us build it very fast. We're not worried about breaking anything. Adding a feature to a monolithic system is far more complex than just building one small unit doing one particular function. So basically, it boils down to is reduced time to market. With microservices, we also have improved system resilience. How does it happen? It's the fact that it's an independent deployable unit. It's not going to disrupt the other services. So it's very different from adding a feature to a monolithic system. The services are not only independent deployable unit, they are communicating with each other in a decoupled fashion over messaging. So minimal disruption, good system resilience. Another thing that happens there is any failure in any service is basically restricted to that particular service. And also, of course, any functionalities that are built using that service. So if it's collaborating to provide some other higher functionalities, those get affected. But the key point is that the rest of the system can keep functioning if there is any failure in the service. Okay. The fact that we have multiple services, now we have broken down those functions and they are running in separate processes, that inherently brings concurrent processing. And not only that, since each service, each function is deployed independently, there's another factor that comes into play. We can scale it independently, depending on the needs of that particular function. So it makes the overall system much more scalable. Now, between these, between the agility, system resilience, and scalability, we have a pretty good set of reasons, pretty compelling reasons to why we should move towards microservices. However, there are some subtle benefits that are missed when people think about what benefits the services bring. So the fact that it's such an agile process and such a quick way to get to market, a quick way to develop because you're focused on single business functionality, it allows business to quickly deploy new functionality and adapt to changing market conditions. So improves business adaptability. And so now the services are communicating with each other over a messaging backbone. What that means is we are moving a lot of data along this backbone, and that enables us to tap into this information and can be used in more creative ways to get better insights into the business and the operation. So that creates higher intelligence for the enterprise. And the idea that it is an independent deployable unit and doesn't disrupt an existing environment in any major way, it also is a key factor in letting businesses to try out new things very easily. So it becomes a big factor in fostering innovation. So let's look at a sample application based on microservices. So what we're looking at here is a set of 3 services which are collaborating to provide a functionality. Now we're looking at the get price functionality, which is dependent on some customer information. It's a personalized pricing. So if we start from the bottom, we are looking at the get price request coming in from the client. It's a synchronous request reply as far as that client is concerned. It reaches the pricing service, which needs customer information. So it does a get customer request to the customer service, gets the attributes that are needed for the pricing service. The pricing service can then compute whatever price it needs to do based on the state it has, pricing of some catalogs, offer books, and so on. Returns the response to that request, and it would emit a pricing completed event, which would be picked up by the analytics service, which can compute some analytics and use it for some other purposes. Now, the key things to note here are each of these services have their own private state, which is distinct from each other. Like the customer service has the customer master, pricing services has catalog or some price books, and the analytics service is keeping track of some of the computed information that is processing on the pricing events happening. The second important thing to note here is look at the varied messaging semantics that we see here. The incoming request is an asynchronous request reply kind of message. The pricing service sends a get customer request to the customer service. But that is an asynchronous request reply because we don't want the pricing service to be blocked while waiting for that information coming in. And we also have an eventing kind of mechanism. So pricing event being generated is just broadcast out and picked up by the analytics service. So based on this and the other things we just talked about, what are the key elements of a microservice? What do we need in the environment? What are the things that are needed to get a microservices application out there? Okay, so there's the business logic. That's what each service is working on. We have private state. We have messaging to be able to send and receive messages. There's routing. Routing with a large set of microservices can get tricky. You need to be able to make sure that the messages are correctly routed to the right service. API management, each service is living up to a service contract and services communicate with each other using those APIs. The same thing with clients making requests to the services. API management is another key aspect. Monitoring and management, since there are so many moving parts, we need good tools to manage those deployments. We want a good monitoring capability. And these services need to be CI enabled to, as we discussed, to be able to have a quick movement from development stage to the various environments up to production. So the key, what we're seeing here is all these elements, they must be easy. That's the only way we can achieve agility in this system. And by making it easy, we do not want to compromise on performance or availability. Okay. So having said that, now let's move to the key challenges. Okay. So messaging is, it seems simple, but it's not as trivial as it seems. There are multiple aspects to be considered when you're using messaging. How do you do efficient encoding? How do you make sure you are routing it correctly? How do you make sure you have exactly one's delivery? How do you handle duplicates, retransmissions, wire formats? So those are the challenges that we deal with in messaging. Private state can be quite challenging as well. It brings its own challenges in terms of how are you actually going to handle it. In transaction management, it's a distributed system, but distributed transactions, distributed atomic transactions are a complete no-go because they are just not scalable. That's been proven across the industry over the years. So what do we do? So that's another challenge to be tackled. Performance. It feels that since we have multiple services, different processes, it's going to be highly performant. But what happens is with multiple services, when we are looking at a specific functionality, multiple services could be collaborating to fulfill that particular functionality. Now, what that means is we are going through multiple hops, which puts a lot of pressure on each service to be really, really fast. So it has to be very performant. High availability, again, multiple moving parts. High availability is going to be a challenge to handle. Each service has to be highly available. Error handling, how do you do error propagation? There are multiple parts. How do you make sure the system is eventually consistent in terms of the transactions that are happening across different services. It's something to be thought about deeply. Then operations, again, the same issue, multiple services, operations become quite complicated. We need some sophisticated tools to deploy and manage those services. So having looked at what the promise of the microservices is and what the challenges are, how have we gone about addressing those? So what we have done is we are using a tool called the X platform from Neve. So X is a memory-oriented platform for building multi-agent systems. Now, agent is a term we have been using for many years. It's basically the same, it's synonymous to a microservice. So what X does is it uses memory orientation or in-memory computing in a unique way to make these challenges sort of go away for whoever is building the services. It makes it really easy to build services. So here's what an application built with X platform looks like. It's a multi-agent applications. The boxes you see with X are each of the agents or the services. What each service typically does is the general pattern is basically the same. It receives a message, it applies the business logic, maybe makes some updates to the state, and then depending on the service, send out one or more messages as needed. That generally is the basic pattern that each of the services will follow. Now, the way X makes things easy for the developer is the developer only needs to focus on the business logic. There is no infrastructural code required when you're writing the business logic. There's so writing it is okay for the X platform. It is a Java platform basically. So the logic is written in pure Java. The state is also pure Java objects. The incoming and outgoing messages are all pure Java objects. There is no infrastructure code that comes to the picture, and we'll look at a sample of this in a bit. Now, so as part of the non-functional aspects that X takes care of, whenever we have the Java objects that you're working with as part of the state, any updates to the state are automatically made durable. That's a key and very powerful aspect that X provides. And the second thing is about messaging. It is a fire and forget kind of messaging. So what that means is the developer can only, all they have to do is create a message and send it out. They don't have to worry about the vendor, what the messaging is doing underneath. And it is assured, X guarantees that it will be delivered to the destination, wherever it's supposed to go. Okay. Now, these two aspects, by treating memory as durable and using messaging in a fire and forget fashion, really frees the developer up out of a lot of those non-functional aspects which really make the development not so agile. So using the X platform has made life a lot easier for us to quickly churn out these microservices for the clients. Okay. X provides various tools to enable quick development of various services. We have Talon, which we use for streaming kind of applications, and Eagle is the one that helps us build out microservices very easily. We have Robin and Lumino, which are the deployment management and command and control and monitoring tools. And we'll have a quick look at those a little bit later. So just to summarize how X makes it simple. So business logic in the service, you write it as pure Java, no infrastructure code. Messaging is vendor agnostic. You deal with plain Java objects, and you work in a fire and forget fashion. State is private and in memory. You update the state, and X takes care of making sure that it's durable. Transaction management is completely transparent to the developer. So the transaction here essentially consists of the time that message is received into the handler, any updates that you're doing to the state, and any outbound messages that you're sending out. That entire thing is treated as a transaction by X, and it done in a fashion that it guarantees that it's either done completely or not. So then performance, X has done a lot of engineering under the covers to improve the performance for the services. And things like smart encoding, high performance POJO generation, and bringing in the whole thing, the 100% in-memory operation. Okay. Error handling can be done using compensating transactions. X makes it easy to generate multiple of those transactions depending on what errors are happening, and easy to hook them up. For operations, I mentioned a couple of tools that X provides, Robin and Lumino, which make it really easy to control the deployments, manage them, and monitor what's going on with the system. So all of these non-functional aspects are taken care of by X. The developer is primarily focusing only on the business logic, and performance, availability, everything is taken care of by X. Makes it really easy to build the services, and easy to snap the agents in and out of your network. Okay. So why is in-memory important for microservices? So microservices is all about autonomy, speed, and agility. Why do we need speed is what we have discussed earlier. We have multiple ops when fulfilling any business transaction, so we want the services to be really fast. What about private state? So private state, I mean, there's approaches where people use shared databases, even private segmentation, but still the data is stored in remote RDBMSs, which introduces a remote hop, as well as it really compromises agility and autonomy, mainly autonomy, because it's a data and database sitting somewhere outside the service, not necessarily in control of the developer. What about out-of-process data stores? Again, one thing is they're out of process, but working with them, then the developer has to be concerned about various complexities, including threading, contention, concurrency, and so on. So again, which would compromise the agility system. So all this brings us down to the solution, which is you take the state and bring it in memory with the function in the microservice, make it private, and put it in memory. And that solves all of these issues. It's in memory, it's really fast, it improves your, it gives you a full autonomy on the state, and makes the whole process of development really fast. Okay. Now, typically a microservice lifecycle goes through these 8 steps. You create a service, you define the state, what messages are, what your service API is, and then the core thing, which is writing your business logic, and the usual steps of test, deploy, monitor, and control. X Platform makes it easy at each of these steps, and we'll go into each of these a little bit deeper in the following slides. I'm not going to talk about it here right now. So creating a service, the Eagle tool in X as well as Talon, there are different types of archetypes, Maven archetypes that are available, which help you generate out the entire required service with the templates, tests, and so on, everything inbuilt. A fully baked service can be built out using these templates, and then you can extend it to your business requirements. So this example shows your standard CRUD service, which is a very typical service in enterprise microservice kind of applications. Let's say it's a customer service we're looking at. The next step is about defining state. State is in X is defined as XML. The Maven archetype has generated this template for us. What we see here is a repository, which is the root of your state graph. And it contains a collection of customers. The customer entity is available. You can extend it to add your business-specific fields. Next step is to define messages, which is also done in an XML format. Here we see different message types: create customer request, and create customer response, and customer created event. We'll bring all this together as we go along. There's a services XML, which allows you to define your service API. Operations here are individual APIs. So for example, the first one we see here is a create customer API. Takes create customer request and throws out a response with a create customer response. Those are the couple of messages we saw on the last slide, created in message when we were defining the messages. Here you can also specify a REST endpoint. Eagle generates out a REST service for you and enables a fully working REST service for you using this information. Now, all these XMLs that we're defining, the build infrastructure is provided with able to generate those into Java classes, and those are the classes and objects that will be available when we're writing the business logic. So we define the state, we get Java objects for the state, we define the messages that gets converted into Java classes, and therefore Java objects available when we're writing the business logic. And we saw the create customer API. So each of those APIs, we will be presented with a handler to write your business logic for it. So if you look at this particular method, what you will notice is it's pure Java code. There is no infrastructure code needed here. What you're doing is something we discussed earlier. Basically, you're dealing with request response, those two message types, which are Java objects, and we have a repository, which is the root of the state graph. You operate on it, you apply your business logic and make updates to the state. And in this case, it's generating out an event, which is another message which goes out to the messaging backbone. So I mentioned earlier, the archetype, if you use the archetype to generate the service, it will, it also generates out a fully baked unit test. Now, the interesting thing with the X and the unit test is those same tests could be used not only to test the API, do the unit testing, you test the API by running this application in a different environment, as well as a fully integrated test. All of those could be done in a very clean, seamless fashion. We saw in the service XML, we could specify REST endpoints. X also generates a web service with REST API enabled, and it is Swagger enabled. So it allows you to get the Swagger documentation out of it, as well as manually test it very easily. Okay. And these services are really easy to deploy either on-premise or in cloud or in a hybrid fashion. That's just a sample of the Swagger generated UI, right, which can be used to test the APIs. For monitoring and control, there are a couple of tools that X provides. Robin, which allows you deployment management as well as some passive monitoring. And Lumino is a visual tool which sits layers on top of Robin. Lets you monitor all the statistics that are generated out of X, put a lot of information together on the UI, and also able to do deployment management it internally uses Robin to be able to do all of that. But basically, Lumino gives you a UI to easily do all of those things. Here's a sample dashboard from Lumino. On the left-hand side, you see the entire system. All the services are available here. You can do management of those services. You can create this dashboard which gives you a holistic view of the entire system. Or you can drill down into specific services or specific agents and see the health of those services. The stats that you see here are there are a lot of stats that are generated by the platform to give insights into all parts of the health of the system. And you can also add your own custom stats by using annotations in the code. So just a matter of adding that and getting your putting your dashboard together is in whatever format you want to see it. Okay. So this brings us to the case studies. I guess we do have some time for those. So it's a simple storage service, SSO storage service. At one of our clients, their website, when that was being built, it needed a fast mechanism to store their single sign-on tokens. Now, as part of their development, they had built it out in using an RDBMS or something, but once it went into QA and performance testing, it was not able to handle the load. So the team was tasked to build out a service quickly. So here we build out the single sign-on storage service. The service basically puts the private state in memory. The tokens are stored in memory. It is running in multiple partitions, and it generates out an API which can be used by the web service to store and retrieve tokens. The key point to highlight here is using X, we were able to do this in just 3 flat hours. It's a simple service, but a production-ready service was built within 3 hours, and it was taken to production actually in less than a week. There's another service we built for one of the customers. So the scenario here was there was a booking service that the customer had, and during the booking service, the room booking service, there was a need to do an inventory check, which the system of records for the inventory was a legacy system. So booking service flow, basically that in the initial stages, that would work fine because there are not as many requests coming in, and the rate was acceptable to what the legacy system could handle. But as the system evolved, there was a need to use this inventory check also in the pricing service to give a better customer experience. And the number of pricing requests are a magnitude higher than the booking service requests. And that kind of volume was not something that the legacy system could handle. So our solution basically was to create this inventory service, which puts all of the inventory in memory. We wrote a wrapper service on top of the legacy service to generate out events, inventory change events, so that we can keep the inventory service state updated. And a simple API to do the inventory check was built in, which was provided to the pricing and the booking service. Again, in terms of the time taken, it was done in about a week and a half and taken to production in less than a month. So the only way so the reason these 2 case studies is what I put together here is to show how using X that we were able to do this, because all we have to focus on was the business logic, and X was able to take care of all the non-functional aspects. That with your business logic, it becomes a fully production-ready system, makes the time from development to production really, really fast. Okay, that brings us to the end of our presentation. There's more information available at these links. If you haven't signed up for the sweepstakes, please go to our booth, sign up for it. I think it's a good odds to get those $500, and also it'll give you a chance to try out the X platform, build out your own microservices. So, any questions? Yeah.
In the same transaction, you can also multiple microservices. How do you make this context? Because you're receiving results from one microservice, use it for another call. How do you approach this?
Okay, so let me try to rephrase the question. I'm hoping I heard it right. When in a business transaction, if you have multiple services collaborating, how do we get the context? So how does the context pass from one service to the other? Okay. So if we go back to the pricing service that we're looking at, right? When the request comes into the pricing service, the request will specify what the customer ID is, for example, maybe, or some other identification for the customer, and it'll ask for, okay, I'm looking for this product, some contextual information as to what the pricing request is. Now, the pricing service itself will have the price book, so it knows, it understands the product, etc., or whatever it's looking for, but it does not have customer information. So it needs to get that confirmed customer information from the customer service. So to talk to the customer service, it needs to know it's the customer service API, and in this case, the information that the customer service is going to need to identify the customer, maybe the customer ID. So that's the context. That's the only context that the customer service needs in this case to fulfill that. It's part of the request, and it will return that customer information. The pricing service can then take it from there. It now has all the information it needs to service the request. Now this could also, I mean, there are other potential applications, like fraud detection or something else, where the request could actually flow from one service to the other, and the response is actually generated somewhere downstream. In which case, what we do is each service would basically add to the context. It will add additional information that it will need and follow it up, pass it on to the request downstream. That's another way you could pass the context on to the downstream system that needs that kind of context. Does it answer?
It's all done from messaging.
I'm sorry, say that again, please.
It's all done from messaging.
It will, when it, to pass it or to get when it, yeah, yes, it'll pass, yeah. It basically takes that information as a DTO, so it'll pass it on further in another message. Yes.
So what happens to the local state when the process fails?
Okay, so what X does is you can run it as a cluster. So you can have multiple backups running for each service. The service can, it's defined in, so what happens is when okay, so we talked about what the message handler does when a message is received. When the message comes in, it applies the business logic, it updates the test state, and it's sending out some messages. What X is doing under the covers is it knows what changes have happened to the objects, because those are generated objects from generated classes from X, and under the covers it is syncing the data back to the hot standbys. It makes sure that a certain quorum is achieved. If there are no hot standbys, then there is high-speed journaling to the disk as well. So it ensures that there is no data or message loss in the event of any of these kind of failures, process, network, machine, whatever. Does that answer the question?
Then you have to do the serialization of the Java objects and send it to the other side?
Yes, X would do that, but it would do that in efficient fashion that it's designed to do that. It's not something that the developer has to worry about.
So you do the backup before the service responds, because if you respond before you do the backup, then if something happens, then your backup doesn't know that.
That is correct. So The way it works is it does this in an efficient pipeline fashion. And yes, so basically a transaction is not considered complete and an acknowledgement is not sent back until this backup is completed. That's correct. But there are efficient mechanisms to not block at any point and make sure that it happens in an efficient manner. Okay. Any other questions? Nope. Okay, thank you for your time. Thanks for coming.